Krishna, am I audible?
Yes, sir.
So in the previous lecture, we have completed up to aromatic compound, right? Aromatic hydrocarbon.
Yes, sir.
Now we are going to do chemical properties of aromatic compound. So here is chemical properties. In chemical properties, first we are going to see electrophilic substitution reaction. Electrophilic substitution reaction. Basically, electrophile will be there and there will be substitution reaction. In this, the first part is basically nitration. From the name, you can say that addition of nitrogen will take place. For addition of nitrogen, there must be some bonds which will break and remove or eliminate from there and add nitro group. So here is the benzene. Now we have to add NO2. That means we are going to react it with concentrated HNO3 plus concentrated H2SO4 at 323 Kelvin to 333 Kelvin, and nitration will take place. One of the hydrogen will remove from there. So substitution reaction, and here is your nitration and H2O will be eliminated. So here is nitration, that is also known as nitrobenzene. Just write it and let me know. If you are done with this, please let me know.
Done, sir.
Now, the next reaction of electrophilic substitution reaction is halogenation. And the from name, you can say that addition of halogen will take place. In order to add halogen, we have to remove something. So how halogenation takes place is, here is a benzene and we treat benzene with Cl2 in the presence of anhydride AlCl3. So a product is formed, that is halogenation, chlorobenzene, and you can see there are two chlorine. One of the chlorine is here and one of the chlorine is here, and hydrogen from benzene will be eliminated or substituted by chlorine and HCl will be formed. In the same way, we have sulfonation. That means sulfonic acid will be added. So how we add sulfonic acid in benzene? First, take benzene and treat it with H2SO4 bracket SO3, or you can write H2S2O7, H2S2O7, that is oleum, or you can say fuming sulfuric acid, fuming sulfuric acid. If you will sum it up, you will get H2S2O7, that is oleum. And if you heat it, then we will get benzene sulfonic acid, That will be like this, SO3, and H2O will be eliminated. Here it is. Please write it.
Done, sir.
Very good. Now, fourth, another example of substitution reaction is electrophilic substitution reaction is Friedel Crafts Friedel Crafts alkylation reaction. Friedel Craft alkylation reaction. This is basically alkylation. That means alkyl, we have to add alkyl group. So here is benzene, and you are going to add chloromethane in the presence of anhydride AlCl3. What happens here is alkyl group, that means methyl will go and substitute hydrogen, and hydrogen will remove from benzene, and here is chlorine. HCl will be byproduct. In the same way, if you have ethyl, that means C2H5Cl in the presence of anhydride AlCl3, this alkyl group add into the benzene and hydrogen will be removed or eliminated. Or you can say C2H5 substituted the place of hydrogen and HCl will be the byproduct. Mohammed, am I audible? Sir?
Yes, sir.
Very good.
Can you go up? I
Yes.
just joined.
Yes, I know. Krishna, are you done with this? Sir, wait for a minute.
Yes, sir. Done, sir.
Very good. So, sir, from here it is started. Nitration, that means addition of nitrogen. Basically, it's all chemical properties, basically electrophilic substitution reaction. Are you done?
1 minute, sir.
Okay, okay.
Some mechanisms of this reaction is also important, right?
Mechanism, yes, but the thing is, this will be enough for this exam call. Your exam is nearby. We will have mechanism in class 12 in details. Uh,
Okay.
your exams date, Krishna?
So 17th March.
19th March, right?
No, sir, 17th.
17th March. Okay. We will have some mechanism which is very important. Are you done?
Yes, sir.
Please write it. Oh, are you done?
Yes, sir.
Okay. Just write it and let me know. Are you done?
1 minute.
Okay.
Yes, sir, done.
Very good. Now, this is basically Friedel-Crafts alkylation. Now we will go for Friedel-Crafts acylation. Next, Friedel-Crafts acylation. Basically, we have to add acyl group. Acyl halide, I already told you about this. This is acyl halide. So how to add this group? Just focus on the screen. This is basically benzene. Now we need to add CH3COCl. This part in this, in the presence of anhydride AlCl3. So since it is substitution reaction, hydrogen will be eliminated from here, and here COCH3 will be formed, and then HCl will be eliminated. In the same way, from anhydride is a functional group, acid anhydride, we can prepare this acylation. We can do acylation. CH3CO whole twice O in the presence of anhydride AlCl3. What happens here is the same product, COCH3. And again, with this, we get carboxylic acid. You can see how many number of carbon, it will be 4. So you can see 2 carbon here and 2 carbon here. So there, here it is, acylation takes place, and here carboxylic acid as a byproduct, you can say. You just have to remember the functional group.
Done, sir.
Very good. Are you done, Seth?
Done, sir.
Very good. Now, if you are going to add 6Cl2 in benzene in the presence of anhydride AlCl3 in dark and cold, we get hexachlorobenzene, chlorine at every carbon. And you can see total 12 chlorine we have given. 6 left, and 6 hydrogen will be eliminated, substituted by chlorine, and 6 HCl will be hexachlorobenzene.
So does this reaction come under Friedel-Crafts acylation?
No, this is not Friedel-Crafts acylation. Friedel-Crafts acylation, that means acyl group you have to add, that is COCH3. And alkylation, that means you have to add alkyl part, that is CH3.
Yes, sir. So, sir, this is halogenation, right?
You can say halogens.
Done, sir.
Done, Saif?
No, 1 minute, sir.
Okay. Krishna, we will do mechanism after completing syllabus before your paper, okay?
Okay, sir. Yes, sir, done.
Very good. Now, addition reaction. Addition reaction, that means you have to add something. Addition reaction is basically, you can see, if you are going to add H2, 3H2 in benzene, this is unsaturated hydrocarbon in the presence of nickel at high temperature, all the double bond will be broken into single bond and hydrogen will be added to this. This is basically benzene and it will be converted into cyclohexane. Okay.
Yes, sir. Done, sir.
Very good. Now, if you are going to add 3Cl2 in this benzene in UV radiation at 500 Kelvin, this will be, again the double bond will be broken and at each carbon there will be chlorine. I just made a mistake. All the double bond will be broken. Chlorine, 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 chlorine. And this is very important to note that this is called benzene hexachloride. Benzene hexachloride. BHC, also known as BHC. So always remember it that the full form of BHC is benzene hexachloride. Done.
Done, sir.
Safe.
Yes, sir, done.
Very good. The
Sir,
next,
there be no double bonds.
what you just said, sir.
There won't be any double bonds
Yes.
in.
If you are going to add something, you have to break the bond now.
Okay. Hydrogen is not removed.
Hydrogen is not removed. Only bond is broken. So basically, in
Okay, sir.
benzene, hydrogen is hidden. All the carbon has one hydrogen in order to satisfy its bond. Okay. So
Yes.
basically, we don't show hydrogen. So in order to add chlorine, we have to break the bond. Okay.
Yes, sir.
Okay. Next chemical properties is basically combustion. Combustion you already know. In the presence of oxygen, you have to burn something. So can you balance this equation? If we burn hydrocarbon in the presence of oxygen, that is understood. What will it give? carbon dioxide plus water. Can you balance it? Krishna, you
Yes, sir.
can see 6 carbon is here, so you have to multiply it by 6. Now 6 carbon, oxygen, count oxygen. uh, First hydrogen, count hydrogen. How many hydrogen? 6 hydrogen, so 3 into 2, that will be 6 hydrogen. Now count oxygen on the right hand side. 6 to the 12, 12 and 3 15,
15, 15.
15 by 2O2. So this will be the combustion of benzene. Okay, in order to balance it, we have a general formula CXHY. Then the number of moles of oxygen will be X plus whatever is the number of Y divided by 4 O2, and then here it will be X CO2, and here it will be Y by 2H2. This is for benzene, aromatic compound. Okay.
Yes, sir.
Okay, just write it.
Done, sir.
Very good. Can I change the slide?
Done, sir.
Seth, are you also done?
Yes.
Okay. Okay, do you know how to do resonance? If I will give you, write the resonating structure. Yes or no? Can you do this resonance of this? Write the structure of resonance.
So can you just show once as revision?
Okay. First, resonance is of two types. First is minus R and the second is plus R. First, we have to decide, or we have to check it, which is minus R and which is plus R. Basically, OH is plus R. That means it will start donating electrons. So this lone pair will move to make double bond here. Okay. Now you can count carbon from here is already making 4 bonds. So one of the bond will be broken and move to this position. Okay. Now see, one bond has 2 electrons and it is shared. Since it is gaining, so here it will be negative charge, and here you can see it is double bond OH, and here it will be positive, and just write it. Again, you have to move the bond here and again here. 2 steps, because if you are not going to remove this bond, if you are not going to break this bond, this carbon will make 5 bond, which is not possible. So again, the double bond will be moved to this side and this negative charge, and again this is basically again this, and this will be like this. So, and OH here will be the positive charge. Again the negative charge will be here, double bond and then double bond and then double bond OH positive. Okay, again if this and then this. So you can see again it will be single bond, and the position of double bond you can easily see here, it will be then here and then here. Now what I want to say is that OH is basically ortho and para directing. OH is ortho and para directing group. How? You can see this is the if I'm going to write the structure of benzene with respect to this, can you tell me which position is para, which position is ortho? This is ortho, this is also ortho, this is also, this is para, right or wrong? I already told you, explained
Yes.
about it. Krishna, Saif,
Yes, sir.
Yes,
with
sir.
respect to one of the group, the left or the right branch is basically the left and the right carbon's position is ortho position, and with respect to this, the opposite side is para. You can see the charge is only at ortho, para, and ortho, not on matter. This is called matter. This is called matter. Okay, so basically OH is ortho and para directing group. Is that clear?
Yes, sir.
Yes, sir.
Or we can say all the plus R group is ortho para directing. Okay,
Yes, sir.
Yes.
okay, just write it.
Done, sir.
Very good. Saif, are you done?
Yes, sir.
Very good. Now going to give you a question on this. Chlorine, and I'm telling you that chlorine is basically plus R effect. You have to do in the same order. Done.
Just a minute. Done, sir.
Very good. Everyone done with this? Now see, I already told you that this is basically plus R effect. So this will move like this, right, Krishna?
Yes, sir.
And you can see here it will be doubly bonded and here it will be positive and the negative charge will be here. Again, in the same way, why you have to show two arrow? You can see if we here, if you didn't move this electron, count the number of bond of this carbon. 1, 2, 3, 4, 5. Can carbon make 4 bonds?
No, sir.
That's why there are two arrows. Sometimes in minus R effect, we have to move only one arrow. So here will be, this will be positive, then this, and then this, and then this. Again, you have to do like this. And this will be the negative. And again this. Now see the position of charge. Can you see the position of charge, Krishna and Saif? Ortho, para, ortho. That's why it is para, ortho para directing. Okay.
Yes.
Yes, sir.
Okay. Just write it.
So will it be always given in the question that this element is
No.
so how we will be knowing it?
I will give you a list of pause plus R and minus R. Okay.
Yes, sir.
Okay. Here your are you done with this?
Yes.
Saif?
Yes, sir. Done.
Very good. Wait a minute. Now we are going to study about p block elements. Okay.
Yes, sir.
new chapter P block. After this chapter, we will have only one chapter left, na?
Yes, sir.
P block. That is basically we have P block from group 13 to 18, but we only need to study about 13 and 14. First, I'm going to talk about group 13 elements, which is known as boron family. So going to write the name of all the elements and how to calculate atomic number in a group. First, we know the atomic number of second period element. Every second period element, you know the atomic number, yes or no?
Yes, sir.
Saif,
Yes, sir.
okay. Boron, atomic number 5. Aluminium, just add 8 in this, it will be 13. Then gallium, just add 18 in this. What you have to do in P block, add 8, 18, 18, and then 32, it will be 31. Then again add 18 in this, it will be 49, and again add 32 in this, and it will be 81. So in a group in periodic P block element, you have to add 8, 18, 18, 32. Is that clear?
Yes, sir.
Now the configuration, electronic configuration in terms of noble gases: helium 2s2 2p1, neon 3s2 3p1, gallium is argon 4s2 4p1, and for 4s2 we will have 3d10 4s2 4p1. Again, in case of indium, we have krypton 4d10 5s2 5p1, and in thallium we will have f 4f14 5d10 6s2 6p1. This is the basically configuration of all the elements from the P block 13th group. Okay,
Yes, sir.
just write it.
Done, sir.
Done, everyone?
1 minute, sir.
Okay.
Yes, sir. Then.
Very good. Now we are going to talk about oxidation state. What is oxidation state? Basically, group 13 shows +3 oxidation state because it has 3 electron in its valence set due to ns2 and p1. 3 electrons, 2 in the s subshell and 1 in the p subshell. Also, group 13 elements also shows +1 oxidation state due to poor shielding effect or due to inert pair effect. Due to inert pair effect. That's why down the group, thallium is more stable in +1 plus order of stability. I'm writing order of stability of +1 oxidation state. Thallium, then we can say indium, then gallium, then aluminum, and then boron. Whereas +3 oxidation state is stable in boron and then aluminum, then gallium, then indium, and then thallium. Thallium is highly unstable in +3 oxidation state. Always remember it. Okay.
Yes, sir. Done, sir.
Very good. Saif, are you done?
1 minute. Yes, sir. Done.
Very good. Now, moving to the best part. Do you know how to calculate oxidation state? Calculate oxidation state of thallium in TlCl3 or TlI3. Can you calculate the oxidation state? Yes or no?
Sir, can you give an example?
Okay, basically, if you are going to calculate the oxidation state of sulfur, just let it X. What is the oxidation state of hydrogen? Hydrogen +1 because
One.
it can only give 1. So 2, and since 2 hydrogen is there present there, that's why 2 into +1 plus X plus 4 oxygen are here, and oxygen is second most electronegative element, and one oxygen needs 2 electrons, so it will be -2. Overall there is no charge, so it will be 0. And in the same way, 2 plus X minus 8 is equal to 0, X is equal to +6. This is how we find or calculate oxidation state. In the same way, we have to calculate thallium. X plus 3 into iodine. How many electrons iodine need to satisfy itself? Iodine from 17th group, it has 7 electrons in its outermost shell, so it will gain only 1 electron, and the oxidation state of thallium will be, Krishna?
Yes, sir. Plus.
+3. This is wrong answer. It should be +3 according to our concept. But I told you that +3 oxidation state of thallium is unstable. Concentrate here. This is very important. Unstable. Basically, thallium here exists as Tl plus and I3 minus. Between thallium and iodine, there is force of attraction, that is ionic bond. So whenever there will be question, what is the oxidation state of thallium in TlI3? The answer is oxidation state will be equal to +1. Is that clear, Krishna?
Sir, could you explain again?
Basically, I told you that down the group, +1 oxidation state is more stable, and +3 stable, +3 oxidation state is very less stable. Okay, or you can say uh, thallium in +3 oxidation state is highly unstable. If it is highly unstable, that means it will not exist in +3 oxidation state in normal condition. Is that clear, Krishna?
Yes, sir.
And if I am giving you a compound TlI3, and if you are going by the basic concept to find the oxidation state of thallium, it will come out to be +3 oxidation state. Is that clear?
Yes, sir.
But it cannot be +3 oxidation state because it is highly unstable in this state. Okay.
Yes.
So basically, thallium, when scientists read about thallium and see, then thallium and iodide ion, between thallium and iodide ion is ionic bond, not covalent bond, and it exists in the form Tl plus I3 minus. Is that clear?
Yes, sir.
Yes, sir.
Let's write it. Please write.
Done, sir.
Done, sir.
Very good. Very good. Now write first oxidation state, then atomic size. Atomic size. Atomic size of what? Boron, aluminum, gallium, indium, thallium. Okay. So the atomic size is found to be boron is smaller than gallium, and then aluminum, then indium, then thallium. This is a very big exception. I'm going to explain it why it happens. Gallium, according to our basic concept and trend, gallium should be larger than aluminum, but aluminum is larger than gallium. Just write it.
Done, sir.
Done. Krishna, done.
Done, sir.
Done, sir.
Just write it. Poor shielding effect. Poor shielding effect. That's why gallium is smaller than aluminum. Third one is basically ionization energy. Ionization energy. Boron has ionization energy. Boron, then thallium, then gallium, then aluminum, and then indium. Please write it. See here, boron is in crystalline form and it has a structure which is known as icosahedral. Icosahedral. This structure is tightly packed and the molecules are closer to each other. That's why ionization of energy of boron is very high. When we talk about thallium, gallium, aluminum, and indium, it's all metal. It's all metal. And basically thallium, due to presence of F subshell, Z effective increases because F subshell has very poor shielding effect, and Z effective increases due to poor shielding effect of F subshell. F subshell. Just write it and let me know if you have any doubt. Krishna, Saf, do you have any doubt? Please ask me.
No, sir.
Okay, just write it.
Done, sir.
Saf,
No, 1 minute, sir.
take your time. Uh, Krishna and Saf, are you free on Sunday?
Sir, on Sunday, there is a maths class.
At what time?
So 6:30, sir.
6:30 your times or Indian time?
Oh, at Saudi time, sir. Yeah, at our time.
Hmm. And before that,
Yes, sir.
before that, 6:30, before 6:30.
Okay, sir.
Are you free or you have some schedule before 6:30?
No, sir, I'm finished.
What about you, Saf?
Sir, from 4:30 to 8:30, I have class.
4:30 to 8:30.
Yes, sir.
Uh, it's your Saudi time.
Yes, sir.
Okay. What about Saturday?
So this Saturday, I have exam also.
Okay. So do you have holiday on Sunday?
I have holiday on Monday.
Okay. What about you, Krishna?
No, sir, I don't have a holiday on Sunday.
And on Monday?
No, sir. Actually, next week I'm having practical exams.
Okay. Okay. Uh, on Monday, there will be online class in coaching. Is there any
Yes,
class?
sir. Yes, sir. It's going
Okay,
to.
got it. I will talk to Miss sir. Hey, are you done with this, Saf?
1 minute, sir.
Okay, please write. Please speed up your writing. We have only 2 chapters left, right?
Yes, sir.
P block, S block. Okay.
Yes, sir. Then.
Okay. Thank you. Okay. Melting point. Since this has a icosahedral structure, boron, aluminum, gallium, indium, thallium. This is non-metal, and being a non-metal, in spite of non-metal, it has highest melting point, then aluminum, then indium, then thallium, then gallium. Why it is so? Because generally, I'm going to write some points. Write with me. Generally, metal have higher melting point than non-metal. But boron has higher melting point due to icosahedral structure. Hard crystalline, very hard crystalline solid. And again, gallium has very low melting point. It melts if you keep it on your palm. So we can write gallium has low melting point because gallium melts when it is kept on palm. Again, in summer, gallium exists in gas phase, and in winter, it exists in solid phase. We can also write gallium melts, or we can write melting point of gallium 30 degrees centigrade, and body temperature is 32 degrees centigrade. Again, gallium is liquid in summer, not gaseous state, and becomes solid in winter. Just write it.
Done, sir.
Very good. Save and let me know when you are done.
Yes, sir. Then.
Very good. Now we will talk about boiling point. Boiling point, boron, then aluminum, then gallium, then indium, then thallium. Because of icosahedral structure, and this is metallic bonding. Since all are metallic bonding, and size will be smaller, bonding will be stronger. That's why down the group decreases. Okay.
Yes, sir.
Done.
Done, sir.
No, 1 minute, sir.
Okay, sir.
Yes, sir. Then.
Very good. Now we will come to the point. Chemical properties. Chemical properties. First, nature of compound. When we talk about boron, it's very tough to lose all three valence electron to form ionic bond. Boron has a smaller size. First electron you will take it out. You have to give energy. Second electron and third electron. It is very tough to remove all the three valence electrons to form ionic bonds. So boron forms covalent bond. Is that clear, everyone?
Yes, sir.
Now, as the size increases down the group, ionization energy decreases. As the size of atom increases, ionization energy decreases. Therefore, kinetic energy, therefore, ionic character increases. It's very easy to lose electron down the group. That's why AlCl3 in solid state covalent in nature, whereas in H2O it is ionic in nature. When we talk about GaCl3, it is same solid covalent and GaCl3 in H2O acts as ionic. But when we talk about indium InCl3 or TlCl are always ionic because it can easily lose electron because of its larger size. So it's easy to lose electron, then it forms ionic bond. Please write it.
Done, sir.
Save.
Yes, sir.
Very good. Now,
Sir, can you repeat the reason why TLCl is always ionic image?
okay. You know that down the group, metallic character increases.
Yes, sir.
How we measure metallic character? An element which can easily lose electron, that is metal. Okay. Down the group, size increases. The
Yes,
distance between valence electron and nucleus is increasing. Okay.
yes,
And if the distance between them is increasing, the force of attraction between nucleus and outermost electron will decrease. So it can easily lose electron.
yes, sir.
And if it can easily lose electron, then it will be ionic.
Yes, sir.
So in every group, the element which is present on the bottom is metal generally. Okay. And metal is bond the type the nature of bonding in metal is ionic. Okay. Metal and non-metal,
Yes,
between metal and non-metal. Now reaction with air. When we talk about air, that means O2 plus N2 both. Okay. First, boron has two forms. One is crystalline. Do you know what is crystalline? And another is amorphous. Do you know crystalline and amorphous, Krishna?
yes, sir. Sir, can you explain amorphous, sir?
Amorphous, basically, these are the solid which is classified on the basis of arrangement of their particles, constituent particles. If the particles of the solid arranged in a disciplined way for long range, that is for crystalline solid. And if a solid, particles of solid arranged in disciplined way for a low range order, short range order, that is amorphous. We can take example as glass. This is also known as pseudo solid. Pseudo solid, perhaps I told you about this. And this is known as true solid, because if you have a window or door of glass, you can see after 10 to 15 years, the lower part is thick and the upper part is thin, because the glass is amorphous and it has fluidity. It has character fluid. It is also fluid, you can say, but the flow is so low, it's so slow that you cannot uh, measurement it in 2 to 3 days. It takes time. The flow is so slow that it takes 10 to 15 years to flow. Is that clear, Krishna?
Yes,
Okay, just write it. So I'm going to write a point about boron. Crystalline form of boron does not react with air. That means O2 and N2. Crystalline form does not react with, but amorphous form of boron reacts with O2 to form, you know that boron has 3, oxygen has 2 valence electrons. So when we will cross multiply it, it will form B2O3, and this is known as boric anhydride. Boric anhydride. Is that clear?
Yes, sir. Done, sir.
Very good. Everyone done? Safe.
1 minute, sir.
Okay, take your time. How's your preparation going, Krishna?
Yes, sir, it's going good, sir.
Good. Done. Safe.
Sir, can you go down?
Yes. Oh, sorry. You should have told me. I didn't notice it.
Yes, sir, then.
Very good. Now come to the point. That is basically when boron react with oxygen, it will form B2O3. When aluminum react with oxygen, it will form Al2O3, right? Everyone, is there
Yes.
any problem in this?
No, sir.
And it will be Ga2O3. Again, indium, it will be In2O3. And in case of thallium, it will Tl2O. And if you are going to write it Tl2O3, and if you are going to check its oxidation state +3, this is unstable. And this is basically stable because it has oxidation state +1. Okay.
Yes.
Now, B2O3 is basically acidic in medium because boron is non-metal and non-metallic oxide is acidic. Al2O3, from childhood, you know that this is amphoteric, right?
Yes, sir.
Amphoteric. Again, Ga2O3 is amphoteric. This indium and this thallium is metal. That's why they are basic. Just write it.
Done, sir.
Saif,
No, 1 minute, sir.
done.
Yes, sir, done.
Very good. Now, boron, since we are talking about air, we will react with nitrogen to aluminum with nitrogen, react with aluminum nitrides. This will form boron nitride. This is known as, and this is known as aluminium nitride. Again, gallium, indium, and thallium do not react with nitrogen. And always remember, Bn to the whole x is known as inorganic benzene. Sorry, inorganic graphite. Done.
Yes, sir. Done.
Seth, let me know when you are done. Okay. Okay, sorry.
Yes, sir, done.
Very good. Now, if you are going to give conclusion, I'm going to write the conclusion about this. Boron plus air will give B2O3 plus Bn. Aluminium plus air will give Al2O3 plus Aln. Whereas gallium plus air will only give Ga2O3, and gallium, indium, thallium does not react with nitrogen, does not react with nitrogen. Just write it and let me know. Let me know when you are done with this.
Done, sir.
Write a topic. Reaction with acid and alkalis. And here amphoteric matter. The matter which liberates H2 gas with a strong acid and a strong base is called amphoteric metal. Basically, the metal which reacts with acid as well as base to evolve hydrogen gas, that is called amphoteric metal. Amphoteric metal, we are going to take some examples, or the list of amphoteric metal is this. These all are amphoteric metal.
Done, sir.
Very good.
Yes, sir, then.
Very good. Write a note. Boron does not react with acid and base both. Okay, but aluminum react with acid as well as base. So when aluminum react with 6HCl, it will give salt plus, you know that acid react with metal to give salt plus hydrogen gas. In the same way, if aluminum react with base, it will give sodium aluminate plus hydrogen gas. Okay, and if you are going to add aluminum in the presence of 6H2O, just see, you are going to add here 2H2O also, so it will give 3H2. And if you increase if you will take water in excess, it will give a coordination compound, complex compound, that is 2NaAlOH whole 4 plus 3H2. This is also a salt.
Done, sir.
Very good. Save. Self done.
Yes, sir.
Very good. Now, what about gallium? Gallium metal reacts with acid. This all reacts with acid. Indium reacts with acid, as well as thallium reacts with acid. Just write it.
Done, sir.
Very good. Saif.
1 minute, sir.
Okay.
Yes, sir.
Very good. Now, halides of group 13. When we talk about halides of group 13, there are two types of halides here, trihalides and monohalides. Okay, trihalide is like EX3 and here EX, and here only one type of halide form, that is TLX, except TLI3. This is basically trihalide, and here you can see E will be equal to either boron, aluminum, gallium and indium, not thallium, because thallium is stable in +1 oxidation state. That's why in this TLI3, TL positive, I3 minus, there will be force of attraction between negative and positive charge. Okay. Oh, just write it, write a point. TLCl3 is unstable, but TLCl is stable because in thallium the stability of +3 oxidation state sorry, +1 oxidation state is higher than +3 oxidation state due to inert pair effect. In the next class, we will complete this chapter, and in next class I will extend the hours of class, like at least 30 minutes. Will it be okay?
Yes, sir. No problem.
Sorry, sir. Can you repeat?
In the next class, most probably on Tuesday, we will extend our class. Like here, it's going to be 11 p.m. I will be taking the class till 11:30 p.m. or 12 p.m. Okay,
Okay, sir.
Okay, sir.
so that our syllabus can be completed before time.
Done, sir.
Very good. Saf.
Yes, sir, done.
Write another point which is very important. Trihalide of group 13 are electron deficient. It is Lewis acid. We have completed equilibrium, right?
Yes.
So you know that what is Lewis acid and base?
Yes, sir.
Yes.
How can you say that BCl3? This is basically boron is from 13th group and this is halide. BCl3 is electron deficient molecule. Tell me, can you say, how can you say that this BCl3 boron is basically, this compound is electron deficient molecule? Krishna, can you answer me? Saif, Krishna. See, how many bonds boron is making with chlorine? All the bonds, total bonds. Tell me.
2 bonds.
3, sir.
3 bonds. That means how many electrons does boron have? 6 electrons.
Yes, sir.
Yes,
And
sir.
how many electrons should have an element to be stable?
8.
8.
So it is less than 8, that means electron deficient molecule. So in order to, and whenever there is less electron, that means that molecule required electron, it will take from somewhere, and whenever a molecule gains electron or withdraw electron, that is Lewis acid. That's why it is Lewis acidic in nature. It completes its octet by back bonding, and the second is dimerization. Just write it. And from here we will continue in the next class.
So what's dimerization?
Dimerization basically, this is monomer. If you will take 2 moles and form a single compound, hold twice, that will be equal to B2H6. This is dimerization. Okay. From 2 moles you are making 1 mole, that is dimerization.
Yes, sir.
Okay.
Done, sir.
Saif, Krishna, do you have any doubt? How is your preparation going?
Sir, can you come again, sir?
How's your preparation going?
So until now, I hadn't touched the new portions yet, sir. I should still cover it up.
Oh, you should. Okay, from here we will study in the next class. Okay.
Okay, sir.
Okay, thank you.
Thank you, sir.
Thank you. Seth, are you done with this?